Hello again. So in the previous two videos I discussed on diffusion process and loss of diffusion. In this video I'll be discussing on the problems related to diffusion. Now in your syllabus they haven't told clearly whether problems will be given or not, but in previous few question papers it's given. Problems on diffusions are given. So to be on safer side we will be dealing, and again in that there are two forms. Now, so far, whatever diffusion we discussed, it was regarding only single solid material. If you remember, when I was explaining the first law of diffusion, I told that keep in mind I'm talking only about single solid material. Okay, so why I told that is this is a case, as you can see this equation holds good for those materials where not just the solid material, single solid material, but when it is subjected to another set of atoms. That is, this equation is for um, if you have heard about heat treatment. Okay, don't worry if you haven't heard about heat treatment. It's just you have that again in detail in the fourth module. In the next in the fourth module we shall be discussing about that. So it means just that you are heating and cooling. You are varying the temperatures on the solid material so as to enhance its properties. So as to enhance the properties of the material. Okay. So that heating and cooling, there are various forms. It's not that easy how we tell. There are many types of heat treatment, how you can enhance the properties of the material. So one such you have, I think you might have heard in chemistry also, carburizing, nitriding, carbonitriding. Okay, so such things. So when a solid material is subjected to another atoms. Now when you say, for example, carburizing means one particular metal will be introduced with carbon atoms. Nitriding means one particular metal will be introduced by nitrogen atoms. Okay, so like that. So in case, that means those atoms are getting into the solid materials. A solid material A is subjected to carburizing means that solid material A will be having the carbon atom. So in its lattice arrangement, these atoms will be coming. The carbon atoms will be coming. Okay, so in such case, when the diffusion is happening, what will be the formula? For that case, Fick's laws won't fit. Okay, Fick's laws is only for single solid material, as I told you. So in such case where the metals are subjected to the materials, solid materials are subjected to other set of atoms, that case we use this. Okay, so diffusion where concentration of the atoms remain constant, like it's a condition how they have maintained this. Diffusion where the concentration of the supplied atoms remain constant. The solution for the differential equation is given by this. That means we have framed this equation considering that whatever the atoms are introduced newly to the current solid material, it is constant. The concentration that are introduced is going to be constant, considering that this equation is formed. Okay, so don't worry if you don't understand the like how all this derived and everything. You don't have the derivation. First of all, we're not sure if they will ask, but they do have asked sometimes. That's why on the safer side I'm knowing this. So for you, we just know that this equation is when a solid material is subjected to another set of atoms. It's not the diffusion just happening within the solid material. Okay, just know that. So after knowing this equation, you should know the terms also, what are them. It's okay if you're not understanding completely because you just need to know the formula. Okay, so Cs is the constant which denotes the concentration of the diffusing atoms. C naught is the concentration of the diffused atoms at the start of the process. Cx is the concentration at some distance x from the source, and ERF is the special function called Gaussian error function. Okay, I know it's quite complicated, but when you solve the problems on it, you will very clearly understand. Okay, So I will, in the video, I will be sharing one video, one problem on that formula, that is this formula, and another problem I will be solving on this one. Okay, so I'll be discussing two problems. The rest are all based on these two only, these two formulae only. Okay, so if you understand one or two problems on this, it'll be easy for you to solve the problems. Okay, so this was about the one of the formula that I'll be discussing later. Next is relationship between temperature and diffusion. Now, Fick's law introduced just the mathematical terms. Okay, I mean to say, he just gave in a quantitative way. Okay, now this Arrhenius equation, it gives a much more enhanced, much more advanced. There you have to differentiate and find. Okay, so here it is no differentiation, it's only regarding exponential. Okay, so Arrhenius equation gives you the relationship between the temperature and diffusion, and a formula is created. So relationship between this. So that is D equals D naught E minus Q by RT. Sometimes Q is represented as E and D naught is represented as A. To make you people confused in the exam, they will only give you the constants. They'll give you Q and they'll give you A. Or sometimes they'll give you E and then they'll give you D naught. So don't worry, it is the same formula that you're going to use. Okay. So what are they? That is, D naught is the temperature dependent on pre-exponential, and Q by E is the activation energy, R is the universal gas constant as you know, T is the temperature in Kelvin. Okay, so always I'm telling you, please, whenever you're writing all these things, the formula, the Fick's first law, second law, no matter whatever, okay, regarding the derivation, when you're explaining the equation, the terms and everything, please explain it with the SI unit. If you miss the SI unit, you will be losing marks unnecessarily, needless to say. So please write it with SI unit. Okay, so now moving on with the problem. So we'll be discussing two problems, and similar to this you can find it in any textbook. Okay, any MSM textbook on problems on diffusion you can find. Okay, so this is problems on diffusion. First problem: calculate the diffusion rate of carbon in iron at 700 degrees Celsius assuming the constants. Now this is the question they have already given you. A, E, T, D. Okay, as I told you, A is nothing but D naught, E is nothing but Q. So they have given here AE. So you will be using this formula only. Diffusion rate means D. Supposed to find the diffusion rate. So D naught is given. R is anyway universal gas constant, that you know. Q is given, T is given. Also remember, when you're solving this problem, T should always be in Kelvin, because in the formula it is expected to be in Kelvin, not in degrees Celsius. Again, if you solve the problem in degrees Celsius, you will again lose marks. Okay, so T should be in degree Kelvin. Okay, so that is done. Now you will be you will be substituting all the values in this particular equation, and then you will get the final answer. Once you get the final answer, please write the SI unit. Again and again and again I'm stressing, if you don't write the SI unit, you will not get marks. Simply writing T equals so and so value will not give you any marks, because it makes no sense. Okay, so this is problems on the Arrhenius equation. Next we will go on to the error function problem. Okay, so for your easy understanding, this problem I have chosen. So read the problem carefully. Nitrogen from gaseous phase is to be diffused into pure iron at 700 degrees Celsius. Now, as I told you, we are introducing nitrogen to a metal, that is iron. So nitrogen is introduced to iron at 700 degrees Celsius. Obviously, for the diffusion of atoms to take place, there should be some temperature. So that is 700 degrees Celsius. If the surface concentration which gets diffused, that is surface concentration of iron, because it's getting diffused, which gets diffused is maintained at 0.1 weight% nitrogen, what will be the concentration at 1 mm from the surface after 10 hours? In the sense, this is the value of T. Okay. After a certain period of time, what will be the concentration? You're supposed to find out. So what is the data they have given? What are the other data they have given? The diffusion coefficient of nitrogen in iron at 700 degrees Celsius is given. Time is given. C naught. It's pure iron. They are telling pure iron. What is the meaning of pure iron? Means there is no any other atoms present. It's only iron atoms. To that iron atoms, you are introducing the nitrogen atoms. Okay, so that is why C naught is 0. Nothing is there. Cx is what you are supposed to find out. Okay, Cs is 0.1 weight%. Now, if you can get back to this, Cs is the constant which denotes the concentration of the diffusing atoms. Diffusing atoms. What is diffusing? Nitrogen is diffusing. What is the concentration of that? 0.1%. So that is why Cs is 0.1%. C naught is 0 because it's pure iron. Nothing is there. Again, what is C naught? Concentration of the diffused atoms at the start of the process. At the start of the process, nothing has diffused. It's pure iron. No nitrogen is there, nothing. So C naught is 0. Okay. Cx is what you're supposed to find out. X 1 mm. At what distance? Again, Cx is the concentration at some distance x from the source of the diffusing atoms at time t. At time t they have given, source distance x they have given. You are supposed to find out the concentration Cx. Okay. I know it's a bit confusing, but when you solve 2-3 problems on this, you will understand. Just rewind the video. Okay, just go back and follow the instructions. You will clearly understand. Okay, so now you're supposed to find out Cx. Also, they will give you the ERF values. That is, for particular x, the ERF is given. Okay, and also this entire thing is represented as Z. Okay, for our easy understanding, this entire thing, that is x by 2 square root of dt. This is the same formula which I discussed here. Okay, don't get confused what formula I am talking. This formula. Okay, so this entire thing is represented as Z. Okay, so x, z you are supposed to find out with this formula. I mean, with this, like they will give you the z, okay, for various values of z, the error function they will give. Okay, you will have to find out the value, okay, x. So that can be done by any of the process. Okay, why I took z as 0.52 is because my value of z here is, it will come as this much. Okay, that is when I substitute x I know, 2 d I know, t I know. So when I do this, I'll get the value of z as something. Correct. So for that z, I should know what is the error function. Okay. So that is what here it's done. Z, error function of z. Okay. Like ERF of z, I need to know something because Cx I don't know. When I find out, what I'm trying to tell is, when you find the value of z, error function of that particular value you should know. Correct. After substituting, you will get this value. This is your z. After you substitute, that value, whatever you get, is your z. See, this is what I have shown here. You have substituted for x. To x is given to everything. Again, it should be in millimeters. T should be in seconds. Okay. Because the formula, the SI unit in the formula suggests it should be in seconds. So that is why I have taken this 10 hours. So these many seconds. doing, after substituting everything, you will get z value as 0.521. Here in the problem they have given 0.5 is so much and 0.55 is so much. Your z value what you have got is 0.52. What is the error function? That is what you're supposed to find out. So that you can find out like this. Any way you can find. Okay, it's up to you. So this is by the extrapolation form, if you remember the graph. So that way we have found this out. Okay. So don't worry, again the clippings of this also I will send you from the textbook or from the materials itself. When the this first module materials, when I give you, in that it will be given, you can see. Okay, that is like 2-3 problems. When you have seen, you will understand what I'm trying to tell. Okay, so next is, you know some value of z now, and then you will be substituting. Then finally you should find the value of 0.5360. Now you know CS, you know C0, you're supposed to find X. Now you got error function of Z as also something. Okay, so error function of Z, I am considering it as 0.5360. Now substituting, I will find that the answer will be ultimately in the terms of percentage, concentration percentage. Okay. Hope I'm clear. If you have not understood, just rewind back. Okay, you will get it. Also browse 2-3 problems like this. It's just the same. Okay, you don't get any other variations like this. So just browse the few other problems. In any textbook, it is the same. You will find it, and also the materials what I'm going to send, you just see 2-3 problems. I have solved 2-3 problems more, 3-4 problems only I have solved on this diffusion. So just see it. We are not sure whether you have problems on this particular formula, but still, to be on safer side, do read it. Please don't skip this formula. Don't skip this problem. Okay. So hopefully you have understood. Thank you. I'll meet you in the next video.